G'day there. You're watching the Aussie BIM Guru, and today on the channel I'm going to share a presentation to the channel that I've conducted for a user group, in this case just because a lot of people obviously can't make user groups at particular times, and it makes a record on the channel as well. So today I'll be talking specifically about pyRevit and the benefits of using it and how you can get started, as well as sharing some actual examples of toolbars and tools I've developed for companies and also for myself. So I'm calling this presentation Unlocking the Power of pyRevit. So I'll be presenting this initially with the Sofia Revit User Group, which Peter invited me to present at. Peter's a really great person in the BIM sphere, has been connected with me for a long time, and I really appreciated the chance to present with them. So thank you, Peter, and also to the Sofia Revit User Group. So most of you probably know about me, so I won't spend too long in these sections, but at this point I'm actually about 11 years into my career. I've moved back to Adelaide, Australia with an architectural background. I've worked in various BIM roles and levels of companies, and currently I'm working with a really large architectural firm in Australia called Architectus. I believe we're actually the biggest one when it comes to headcount and cover most sectors. And I'm working as both the computation and BIM lead, and I'm still producing videos in my spare time when I can. So currently I work with Architectus via a parented entity called BIM Consulting that does BIM consulting. Currently we're a pretty large firm, about 400 people before we merged with Conrad Gargett recently. So we cover all sectors in the market and have now began to cover other sectors via our collaboration with Conrad Gargett as part of the company. So we have a specialist dedicated BIM department and an outward facing component called BIM Consulting, but effectively we service the company in-house with all their BIM needs, systems, templates, and I specifically deal with the computation and automation solutions that we provide in-house as well. As well as that, we have a web developer, actually two of them, who also develop different types of apps. So it's a very varied and interesting group to work for, and it's really what led me to work for them, just this dynamic nature. I did sub-consult to them since October 2020, but did join formally last year in 2022 and now work full-time there. So it's a really exciting time of my career. I'm really enjoying it, and it's really nice to work with like minds and people with different experiences and opinions in the BIM sphere. On the side, I'm still not really consulting, but now focusing on just maintaining my Revit templating and content and some scripted solutions via my course platform, courses.bimguru.education. I have some free models over on the platform if you're interested in seeing what I do there, and also some paid content and a course over there as well. And I have a Dynamo course specifically, which for $50 is pretty great value, I think. Feel free to check it out. Anyway, I still manage the channel, started this back in 2019, really because I was just tired of the industry sort of not sharing what I saw to be some really useful information or not sharing it as readily. So I decided to sort of start doing that and join a crowd of people that I guess I didn't even realize were there until I really joined this community, but really have sort of helped hopefully amplify some of the noise around sharing workflows around Revit, Dynamo, Grasshopper, and various other platforms, as well as BIM itself. I focus usually on everyday workflows, typical scenarios, and hopefully scripts and processes that relate to real practice. About 35k plus subs and 350 plus videos. Anyway, you're already on the channel, so you're already checking it out, so thanks. So onto the topic at hand, pyRevit. I'm really just going to focus on what it is. I'm going to touch on Dynamo and talk about whether it's versus or plus, or whether it's just a completely different approach, or whether you can use both of them. I'm then going to show some Python fundamentals, and then some examples of actually applying this in the context of Dynamo and pyRevit. And finally, we'll just look at a toolbar setup and some basic examples. So as Autodesk tells us, we shouldn't be waiting for progress. We should be making it. Autodesk has developed an API for Revit that gives us very deep access to the program as long as we know what we're doing. And luckily there's a Python wrapper inside Revit as well, which lets us talk to it in Python. So programming to me is a really great way to get around limitations or issues in our platforms. It lets us really use logic that we can take to other programs in the future as well, such as using C# or Python. These skills are very transient. Just learning Revit obviously won't feed into other programs, but learning to program, that will take you places outside of Revit. Ultimately, I see it as giving us absolute control over how our programs are functioning. If we don't like the way something works, we can build our own feature and make it work the way we want to. We've seen historically this works with things like Lisp in AutoCAD. There's many ways to interact with programs, and this is currently one of the modern paradigms that I'll be talking about. It also lets us collaborate openly. For example, sharing resources through GitHub is something quite common these days, which maybe would not have been as common, say, 30, 40 years ago when it came to distributing IP or ideas or licensing our content. It also just lets us just get rid of boring workflows, things that we don't really want people to be doing when we're delivering architectural, engineering, construction services. We want to be doing the most suitable programs, suitable tasks for people, not programs. So programming is definitely a perfect solution for some things, but not everything, but it's definitely helped us really break through the silo walls around our industry when it comes to knowledge sharing. It's a real challenge. Most of us aren't programmers at heart. We didn't join architecture to be programmers, but some of us have really found it, and it talks to us in many ways. It does ask us to learn a lot of new things and think in different ways, to challenge the way that we think, to question the boundaries of intellectual property, and also to question where a business draws value from. I think when you can deal with those barriers, there's a lot of potential for what you can do with programming in AEC. I always recommend people don't fall back on excuses now that we have ways to work around them. A lot of people say, I didn't become an architect to learn programming. Sure. Did you become an architect to use Revit all day? Probably not. So don't. Get a computer to do it for you. It's way more fun. Stop waiting for the magic button. I think everyone's realizing with the Revit cycles coming out that we're not just going to get all our problems solved by Autodesk for us. They're not going to wipe our bum. We need to actually start being proactive and taking advantage of the tools they're giving us that allow us to build in the meantime. So Dynamo came along quite a while ago now. I saw it as a bit of a lifeline to Revit users struggling to learn to program in C#. Dynamo as a visual programming platform really helps people understand their code without needing to understand how to program straight away, or at least how to program at a deeper level that was usually the necessary entry point before this. Technically open source, a lot of people don't realize that, but it is technically. Invented by Ian Keogh, who's over at Hypar now. Definitely check out their work, quite interesting to see where the direction's moving. Currently managed through Autodesk and integrated into various programs that Autodesk is managing. So most of us have probably used it and are quite familiar with the ins and outs of it, so I won't really spend too long talking about it. But inside Dynamo, there are Python wrappers that allow us to use either IronPython 2 or CPython 3. It draws upon various DLLs or libraries, dynamic link libraries that store commands that can be sent to Revit in order to instruct it to do things. So it's a pretty useful tool, and it's a great way to wrap some of this functionality up. Dynamo is also really great, even though it's not perfect. It's really helped people to think like programmers, or to realize that they were capable of thinking like programmers, and also help them build everyday solutions. It's brought people together, it's created user groups, it's really helped people. And whilst I don't use it every day anymore, I still appreciate it for what it really gave me, which was an inroad into programming and also to make my job and day much more interesting. So if not for Dynamo, I am 100% sure I would have left architecture, probably would have left the industry. So thank you, Ian, that definitely helped really save my interest and hope in the industry. I'll just look at a Dynamo script maybe briefly, just for people that aren't quite aware of how it works. I think I've got one on file, so somewhere in here, might have to dig for it. Just bear with me. I thought I had one. This is actually a test run, so it's a good thing I actually tested this first. There should be a Dynamo script in here somewhere. Ah, of course, there it is. It's in the folder above. So I'm just going to open up a Dynamo script, and this Dynamo script is built to be a fairly sophisticated tool. It's not built in a way that a standard entry-level user to Dynamo would build. It's to the point where you've become quite familiar with the tool and started to use various integrations and packages for Dynamo in order to really customize the experience the script provides. So this script is made to deal with bulk revisioning of sheets. It's one of my favorite examples in Dynamo. It also contains some dependencies in order to set up a user interface. We have data shapes and crumple. Everything in green is generating a user interface. So we can see nodes being connected together, getting all revisions, getting all sheets, and then also getting a remove or add option, taking our outputs and either adding or removing, and finally sending a message to the user. You'll notice that over about half of the nodes in this script are custom nodes. They're not ones that come with Dynamo. Now, Dynamo's got a lot more nodes in, say, 2024. You go back to 2020, most of those nodes aren't there. So there are some issues already emerging with the challenge of using Dynamo and maintaining dependencies. You'll notice I don't really have a lot of dependencies. I try to avoid them. I try to minimize them to my package. If I hit run, we'll get our user interface, which will contain a few things. And you notice it didn't just load straight away. It took a bit of time. But we can pick a revision. I can pick one. I can pick a few sheets. Let's add a revision. And we can see Dynamo's very capable of executing a workflow quite comfortably whilst being fairly visually approachable still. So it's a very great tool in that regard. Now, there will be some challenges that come with Dynamo over time, and we'll touch on them shortly. So the limitations, there's many of them, and it's not because Dynamo is a bad tool. It's because Dynamo is intended to really help people enter programming and use it at a very comfortable level, which means you have to accept some things won't work the same way they do in more advanced levels of programming. At times, I've probably been a bit harsh on Dynamo and potentially overstepped the mark and complained about it and said use different tools instead. And I've come to appreciate that there's different solutions for different problems, but there are some serious challenges with Dynamo. Most of them can be worked around to some degree, but some of them are inherent of visual programming. For example, you become dependent on custom packages pretty fast. When you need to do very custom things, you're going to need custom things to do them. As well as this, a lot of advanced things don't come out of the box, such as building a user interface. This is a custom set of tools. As well as this, deploying scripts can be quite challenging. Dynamo doesn't usually like running off of a server. It can, but there's a lot of things that it doesn't like drawing off of servers, such as packages. So you will pretty quickly need to develop ways to deploy packages around your company if you do want to expand Dynamo at a company level. I've tried this personally, and it was a serious challenge. You're going to need your IT department to be your best friend, and sometimes they're not. As well as this, control flow in Dynamo is very linear. You go from left to right. You can create pathways and logic, but usually you're going to fall back on Python or C# in order to create very advanced logic pathways. As well as this, the script will usually have to finish. It has to get to the end, which means sometimes if you don't want something to happen, you're going to have to put your graph into a warning state where it says, sorry, an error's happened. Maybe something didn't process, but you still hit a warning anyway. Usually Dynamo Player is the main way to deploy and view scripts. It's a great tool. A lot of other visual programming tools really need a Dynamo Player, such as Grasshopper, but at the same time, it can be limiting in the experience and interface that the users deal with. There are some remedies. There's various apps such as Orchestra or Relay. I believe Dyno is no longer running, but they're not necessarily either always free or they're not always easy to deploy as well. As solutions, some are free but come with the gotcha that you have to deploy them and manage them. Of course, that makes sense. Open source software. You've got to put some effort in. But at the same time, they're not necessarily, I think, natural remedies that most people can fall back on. So Dynamo is really just the tip of the iceberg. It's packaging more complex code for the user, but that doesn't mean you can't learn this more complex code and use it in different ways. There are various journeys I see through your goal. As a programmer, you can go down the Forge or the add-ins path just directly, especially if you're a computer scientist or you just want to learn it the complex way. Nothing wrong with that. You can take the Python path, you can go through Dynamo into Python, you can go across. There's all sorts of pathways. You can be a scripter. Maybe you're happy to just finish with Python and pyRevit. Or maybe you want to go all the way through, go for profit, fun, make a firm, use Forge, or maybe you want to do both and you're going to go through these in order to get to your destination. There's no wrong way to do it. The only wrong way to do it is not to do it, in my opinion. But anyway, that's personal. So obviously written programming is quite different. Not everyone's going to be able to learn this way. It took me a long time to get my head around written programming, but now that I use it, I find it so hard not to use written programming, mainly because you get access to very good control flow and iteration. You can be very specific with what you want your code to do. As well as that, visual code is not always clean. Sometimes it's hard to make it look clean to the user, especially if you're drawing upon things from further back in your process and trying to pull them all the way forward. It can get quite messy pretty fast. As well as this, you can tap into various APIs, libraries, with just a few words. It's very easy to draw upon dependencies, as long as you have a means to access them, of course. I think over time, it actually becomes easier to read these. There are a lot of programs out there dedicated to making written code very easy to use with things like IntelliSense to be able to sort of know what you're looking for, or recognize variable names or library methods. So there's definitely things that definitely make written code a lot easier over time. The Revit API, or the application programming interface, is how we can basically talk to Revit. It's Autodesk's olive branch to us, saying, yes, we're not going to let you all the way behind the scenes, but here's a whole bunch of commands that you can call on to do things in our program. So not everything in the API is available, but a lot of stuff is. Over time, they're exposing more parts, which usually involves some rebuilding parts of the program from the ground up. I think the hardest part of actually moving on from Dynamo is learning the Revit API. It's not learning the language, it's actually learning what you're going to tell the program to do. There's a really great website, Revit API Docs. It's actually, in my opinion, one of the better document websites out there for an API. They've done a really good job, I think, in connecting what is not necessarily a logical API in every aspect, but it contains classes, methods, enums, properties, lots of examples in both Python, C, VB of how you can interact with Revit. You're not always going to get the Python syntax given to you, but typically it's not too different to the way it's presented to you on the API docs. So Python is awesome. I love Python. It's a really approachable programming language. I think it's programming for people. It's a really good language, fast growing, so many resources out there, very versatile, used in a lot of different applications. So there's heaps of great examples out there, not just for Revit, but also for other industries. I find it easy to read and also to write, and it does have a lot of potential. Of course, it's not going to be as direct in talking to a computer as a language such as C#, depending on the program you're talking to. But it definitely is a really comfortable language for the most part. It's also sort of where I ended up in the meantime. I hadn't really dove all the way into C# at this point. So where can you learn it? Well, there's the Dynamo Python Primer, a great website. I've got a series on Python on my channel. There are custom packages where all the Python is exposed, such as Genius Loci, Clockwork, Spring Nodes, and also my package Crumple. I'll probably touch on a few key terms and techniques in Python, just so we can learn about it. But I have a package called Crumple you can check out in Dynamo, where pretty much all the nodes are exposed to Python that you can go and open and view and see how the Revit API works. So I'll give you a little crash course in Python. So I'm going to have to do a little bit of programming, which is always hard to do live, but I'll see how I go. So I'll probably just write in Dynamo actually. I'll let Dynamo sort of be my viewer into Python, or my IDE, my integrated developer environment. So I'm just going to create a Python script and edit the script. And I'm going to have a big boilerplate of stuff that I usually use to get my script started. I'm just going to delete it all. So in the context of Dynamo, we're typically dealing with a variable number of inputs, even no input, and we're also dealing with a single output. So I'm just going to start coding some basic things. So for example, in Python, we usually declare variables. For example, my string can be represented using double or single quotes. That would be a piece of text or string. I can have my integer, which is a single number without a floating point, or I can have a float, or a double in some languages, 2.5 with a floating decimal. I can make lists. Lists are very easy to declare with square brackets, and I can also pass variables forward and do things with them. For example, let's make a list, and let's just say my output is my list, and see what we get. And I can see I've just declared, in this case, a string, an integer, and a float, and stored it into a list. So it's very easy to move data around, reference it, and call on it. I can use logic as well. I can say if the length of my list is greater than 2, I can say message equals, wow, that's a big list. Otherwise, and I can say else, I can say message is boring. So I can start to combine logic in my script, and I can now say, well, what is message? And message can be one of two things. In this case, I can see that, wow, that's a big list. If I take something out, then my other condition hits. So you can see it's very easy to set up basic statements. One really cool thing you can do in Python is you can use what's called looping or iterating. So in this case, I'm going to make what's called a range. I'm going to say my range is equal to an object range, which starts at 1, goes to 5 with a step of 1. And I can say for something in my range, meaning I'm going to work through the range, which is a list of numbers. I can, in this case, say, let's make a list. So I'm going to say out list is an empty list. And then I can say out list append. And I can append the square of each number using the multiply command. And you can see that I'm able to work across. Oh, this now I've done something wrong there. I've got an error. Of course, I forgot to say in for this in my range. And there we go. You can see I'm very quickly able to work across a list of data, and I can work across lists of data with a lot of things as well. Let's say we want to maybe make a function for this instead. Well, in this case, I can make something called def, and I can say I want to make a function called squared and apply it to n, and then I can return n times n. And then instead, I can use a function to generate the same outcome, but maybe I want to make it cubed, and immediately I can pass different context into the model. So there's a lot of really interesting tools and techniques available. You can also do things which I call sort of catches, try, except. Let's say in this case we have maybe a list, and instead of a range, I'll just say my list, and we'll say we've got A, 2, and 0. And let's say we want to divide 10 by these numbers. Well, we know we're going to get a few issues here. If we divide by 0, that's not allowed. And if we divide by a letter, that's not allowed either. So if I say for I in my list, in this case, if I say 10 on I, we're going to get some errors. In this case, we can't use an operand for int and string. And we're also going to get a divide by 0 error. But if I say instead try, and then I say except at list append none, we're able to create error-free code that in this case catches those scenarios. Now we don't have to append none, we can also append something like 10. So we can create pathways for our code to work through that would usually cause errors, especially in a visual programming environment. So that's just a few examples of the versatility of Python. While I'm here as well, I'll just quickly show crumple. So if I want to grab a node, such as maybe I'll just find a good one. Let's say we want to get the elements and we want to delete some elements. So you can right click, open nodes, and inside it you'll find Python with Revit API available for you to reference. Pretty cool. So just a bit on Python, but I guess we're going to move on from Dynamo and sort of start heading towards pyRevit. So now that we know a little bit about Python, we'll have a look at Python for Revit, pyRevit. It's an add-in developed open source by a developer called Hassan, who also manages Rhino inside with McNeil, that allows you to access the Revit API. It runs through, I believe, the Python shell, and allows you to send Python code into Revit using a really great interface development environment. So in this case, you can develop toolbars, buttons, ribbons. You can also run Dynamo scripts. I don't tend to use it for that, but you can. You can also leverage events in Revit, so hooks, and run scripts when they're detected, and many other things. But it is supported by a few other people in the community because Hassan's only one person, but luckily being open source, from time to time people jump on and help. So if you are interested in seeing it, do go over to Hassan's GitHub where he does have information on this. It has installers, source code, readmes, guides. It's a fantastic resource. As you can see in the contributions document, Hassan is very busy. So what does pyRevit solve? Well, for me, one thing it does solve is deployment. It does seem strange that having an add-in is actually easier than Dynamo, which is built in. But it just comes with so many things that you would not usually have in Dynamo. For example, it has a forms library to develop user interfaces. I find it's much more accessible. Being on a toolbar and having different types of flow control available really makes it easier to build tools that I think users are more comfortable running. And it means you relinquish dependency on custom packages generally. With the gotcha that you have to obviously learn the Revit API and Python. It's important to note that pyRevit's also free and open source, which is meaning that, like, whilst it maybe won't always be maintained and developed as much as a program that's paid for, it's very unlikely to become abandonware where no one actually wants to update it, even though they're being paid to. There are programs out there like that. I won't say their name, but I'm sure we know a few of them. So deployment is quite easy. You need pyRevit to be installed on the machine, obviously via an installer. There are various ways to semi-automate or automate that process, usually involving IT. There's a CLI install method if you're interested in looking into it. But from there, you open Revit and it's there. There's a docs website, which I'll probably just jump over to quickly. So here we are. And it has various libraries or sections of pyRevit and shows you various commands you can use as well as the keywords you pass to them in order to generate things, and also has examples. It's a really great set of docs that you can read and reference. I use it very often. So I do recommend giving it a good read before you really dive into pyRevit, but it has some really interesting tools. For example, an error suppressor is quite interesting. It can do a lot of really great things. There's a developer docs, which has more information in a tutorial format, talks about things in a less documented manner, which is also great too. So you can run Dynamo scripts like this from pyRevit, but be aware that you are going to have to, in this case, actually use user interfaces like something like data shapes in order to allow users to interact with your tool. There are tools that come with pyRevit. Some of them are quite volatile and do pretty heavy things to the model, such as wiping out all subcategories. So do be careful if you're deploying pyRevit. There is an option to set a flag in the ini file that comes with it, the configuration, to disable these tools, which I actually do where I work. Toolbars are typically structured into a few layers. You have the extension, which holds it all together. You have the tab, which in this case is at the top of the ribbon where you pick the tab to go to. You have panels, which you can have any number of, as many as you can fit in the tab. And then you finally have buttons, such as push buttons, pull downs, all sorts of things. And these are usually where your tools will either live together or be the tool itself. You can find this toolbar with many more tools over at this link on my GitHub called guRoo. So toolbars look a little bit like this. They're basically folders and files, and it becomes very easy to put these together very quickly. In my opinion, pyRevit is a rapid deployment toolkit. You can develop little tools and basically have them ready within 10 minutes if you know what you're doing. There's a library for making user interfaces called Forms, which has general alerts, text inputs, list selection, all sorts of things. pyRevit does give a console window that I'll show you quite shortly, but I usually prefer to use Forms in order to really make the tools appear as an app. This is the console in pyRevit. You have some pretty cool tools in here, such as one that's called Linkify, that lets you create little buttons that take you to things in the model. You can do things like get the path of the script being run and use that to deconstruct the path into other resources stored within the toolkit. You can draw data later from files you can store inside the computer called pickles. All sorts of weird and wacky and awesome things that Assan's built into the toolkit. It can do a lot. So generally you'll start off scripts using the Revit API using what's called a filtered element collector. These are basically a query to the Revit DB asking for a set of objects that meet a particular criteria. Whenever you call on the Revit DB in pyRevit, you'll do db dot in front of a reference to the API, which is a little bit of a difference if you're used to writing Python in Revit or in Dynamo. You can see here in this case, I'm asking for all the sheets in this case in the document. And that's a filtered element collector structure you can use in pyRevit. So there's lots of types of buttons and tools that you can create in pyRevit. Here you can see guRoo with the pull down, push buttons, stacks, all sorts of things. We'll have a look at that in a sec. But you can nest tools, you can do all sorts of things with them. You can create pretty dynamic toolbars with lots of different tools built into them. You can also pick up events using what's called hooks. In this case, you can see, for example, you can build sync timers, you can intercept tools such as modeling in place and say, are you sure you really want to do that? And then let it run or cancel it potentially. If you've ever used Guardian for Revit, you can basically build those types of tools on the back of hooks. It's good not to use hooks that trigger too often, so do be careful if you are using them. Where I work at Architectus, we have a toolbar called pyRarch or pyRevit for Architectus. Where I develop over 150 little tools in-house. A lot of them began their life as Dynamo scripts and are currently in a Python script instead, and they do all sorts of things. I'll show you a few of these. I can't show everything in this toolbar for various reasons, but I'll show you some of the cooler tools. And guRoo is my open toolbar that I've developed separately that contains sort of tools of a sort of different nature for the most part. Some commonality where it doesn't hurt. but that's an accessible open free toolbar as well. So let's just do a little crash course in pyRevit, and then we'll have a quick look at some more advanced tools and tool setup as well. So in this case, I'm just going to minimize this tool, and I'm just going to again be doing some live code, which is always challenging. I might quickly cover some pyRevit references that I'll be using. So if we go to forms, I'm going to be using a few forms in here. I'm going to be using the alert form, which just brings up a interface and gives you an option to either stop the script or keep going. I'm also going to be using a function to stop the script, which is a really unique thing. I'm going to be using script.exit that actually lets us terminate the script at that point. Really great when you want certain conditions to say, don't go any further. We don't want to run any more of this script. I believe as well, I'm going to be using Revit transactions, and there's a special type of transaction that pyRevit offers. I think it might be in here. No, it's not. But effectively, it allows us to just hold everything within a transaction rather than having to start and commit and stage the transaction like we usually would. Anyway, I'm just going to show you pyRevit in action. I think it's just easier that way. So if I just open up Revit, I'm just in a free sample model that's on my website. In this case, I'll go and add a toolbar, which I can just do through pyRevit like this. Currently, I've got the ABG toolbar, which I'll get rid of. I've got pyRarch, which is a copy of the Architectus toolbar. I'm going to add guRoo while I'm here as well. App data. So this is how easy it is to add an extension. Done. I'm also going to add a testing directory. So this is just going to be a temporary directory just to show you how a tool's set up. And this will load both guRoo and also a test directory that we can work from. So we'll look at guRoo and pyRarch in a little bit, but there's one and there's the other. So you can see they look quite different. We're going to focus on test tools. So we have two tools here. We have one tool here, testing and testing 2. So what do these look like? Well, if I go to the folder where I'm keeping test tool, we have an extension. So you can see the folder ends in .extension. We have a tab, which is in this case test tool tab, test tool panel. And we have test tool and test tool 2. We're just going to have a look probably at test tool 2, I believe. So I'm just going to use Notepad++ as my editor. You can use different ones, of course. This is a very basic editor. Here we go. So this is just really an empty script we're going to start writing sections for. This is a bundle file, a .yaml file, a YAML file, where you can declare certain aspects of the script, such as the name being testing 2, and the tooltip being just testing this. So in this case, I'm going to go to script, and we're going to begin by saying from pyRevit, import db for the Revit API, Revit for some special Revit commands, script, and form. It's important to note that I'm actually just working in a py file, a script file, within this folder. I'm not working in an environment that forces me to close Revit whenever I want to retest something. I can dynamically change this file and then rerun it and see what's happened. I'm going to say that first of all, I'm going to store the current document to revit.doc, just so we only have to declare it once. Now I'm going to, in this case, actually get all the sheets in the model. So I'm going to say sheets is equal to db.filteredElementCollector. So I'm using the filtered element collector class and applying it to the active document. I'm going to be getting elements of class, and then again, it's an API reference. I'm going to say db.viewSheet to elements, which I believe probably isn't necessary in this case, but there it is anyway. So at this point, what we would have is all the sheets in the model. So I can just say print sheets, save the script, hit the button, and the console should show us, cannot import form. I think I've done forms, it's got to be plural. So see a very quick change, one typo, rerun, and we're in business, no problems. And there's all our sheets. So this is the pyRevit console. I usually use it for troubleshooting for the most part, but it is a handy tool nonetheless, and you can do various things with it. Now we're actually going to check if we actually want to do something. So I'm going to say here that I'm going to make a form called ask user, and I'm going to, in this case, store this as a variable. And to this, I'm going to pass an alert form, and I'm going to ask them firstly uppercase sheet names, And let's say the title is equal to hello there. Now I'm going to say yes is true, no is true, okay is false, and warning icon is false. Now how do I know all these things? Well, I've done these that many times that I know what these things are called. These are keyword arguments. So on pyRevit, under forms and alert, you can see that all the keyword arguments are listed out with default values. So you can see okay is true by default, so I have to say okay true is false. In this case, exit script. We can see warn icon is typically true, so I don't want to show a warning icon. But we can see as a result, we'll get a little form for the user. So if I hit this button, there we go. We can see we created a little message for the user. Now, if I say yes, it's going to pass through that outcome to the form. If I say no or cancel, in this case, the user input is going to be none. So I can say in this case, if not, ask user. Well, we know in this case, we want to stop the script. So if this is satisfied, I say script, exit. And let's say after this that I want to print, here we go. So if I hit the button and I say no, we can see that we've actually successfully terminated our script. If I say yes, here we go, we keep going. So it's a very great tool for flow control. There are sometimes better ways to do it, but in this case, I find that a really easy way to terminate a script. In addition to this, I'm going to make a function which is going to attempt to make the title, or sorry, the number of a sheet uppercase. So I'm going to say define sheet upper name. We'll do name or we'll do name. And we're going to try to do this just in case something doesn't work. So I'm going to say try, and I'm going to firstly try to get the parameter of the sheet. So I'm going to use the lookup parameter, Revit API method here. And I'm going to look up the parameter sheet name. I'm then going to say, in this case, what is the value of the parameter? And I'll say that is equal to the parameter as a string. So I know I'm dealing with a text-based parameter here. And then we can say, well, what's the value in uppercase? And we can say this is going to be the value of the parameter upper. And that is a native Python method there where you can make a string uppercase. We then say that if the original value is not equal to the new value, the upper value, then we know we want to change it. Otherwise, we may as well not bother. It's a waste of time. But in this case, we can now take the original parameter and we can set it, which is again the Revit API we're using here. And in this case, we want to do the uppercase parameter. And we can say return 1, or if we didn't need to actually change it, we can return 0. And you'll see why I'm doing this in a second. If we couldn't do that, then I'll just say return 0. So our function is only going to return a value of 1 if we actually change the case of a sheet. Otherwise, it's going to return 0. I'm now going to actually run the task and use my function across my sheets. So I'm going to say in this case, pass count is equal to 0. Currently, nothing has happened. Now using a Revit transaction, which is a special pyRevit syntax here, which means that we're only going to use this transaction within the with statement. I'm going to make a transaction called rename sheets. And within this transaction, for each sheet in sheets, I'm going to take my pass count and try to raise it using plus equals by the outcome of applying our function to the sheet. So that's why I'm returning a number from my function. So that will both change the name of the sheet, and at the same time will also add whatever was available onto pass count. So if we change a sheet, pass count goes up by 1. So it's sort of a shortcut. I do use that quite a lot as a method. And finally, we just want to print an outcome to the user. And we can say the pass count as a string, sheets renamed. So hopefully if we run this, we should see an impact here. Now at the moment, most of my sheets are actually not uppercase, so I might just quickly add a couple with like a lowercase character. So we'll say, do we want to go to uppercase? Yes. 3 sheets renamed, and there we go. We can see that our sheets have now changed the case. Let's just very quickly make a small change. Lower. Rerun it, and we're going to see, obviously we're taking it to lower, but check it out how quick that was. Super easy to make a little change to the script. and test it, and we're in business. Very convenient. So there we go. So that's just an example of developing a little tool in pyRevit. So let's have a look at some more advanced and developed tools. I might begin with, in this case, maybe pyRevit for Architectus. Now I can't show every single tool in this toolbar, of course. Some of them are a little bit sensitive to the company's workflows. So, but some are really simple, just like take me home. And it'll just take me to the opening screen. So all that does is ask the document, what is your start view? And try to open it. So I think it's under manage, you can set a start view. And it just tries to say, what is that? Take me back to it. So some tools are really simple. Other ones are a little bit more complicated or interesting. For example, if I go to a floor plan, I have a tool that I built a little bit before I came to Architectus, so I do use it elsewhere, called pre-select, which lets me pick pre-filtered selections. So I can only pick walls once I make a selection here. There's a little bit of a delay because I do have a logging process that just failed because I'm not on the work system. All my scripts report to server. And there we go. I can see I can form a very specific selection of the model. Very cool. I have things like detective tools, which ask me about things like which views are using a particular filter or template, or what sheet is a view currently on, or which view owns another view. I can say, which views are using a particular filter. And I want to see which ones are using the CES call-out elevation section for floor plans. In this case, it looks like none of them were, so nothing happened. Probably not the best example. Let's show a different one. Maybe let's revision some sheets. I can up revision these sheets. Again, it's going to take a little bit longer. I've got a little notification about large UIs. Pick a revision. It's already detected I've picked some sheets, which is an inbuilt pyRevit feature. So it doesn't actually bother asking me to pick sheets. Now in this case, I believe these already had a revision on them. So I can go to detective and I can say which views have a revision. Pick my revision once it pops up. And this is a Linkify window. So this is where you can actually click and visit things using a little UI in pyRevit. So I use these quite a lot when I'm doing auditing or checking out sets of objects, but it's pretty powerful. Probably just a couple of other examples. The transfer tools are pretty cool. Again, something I sort of discovered before I came here, but let's say you're dealing with a project and you want to selectively transfer some things over. Well, I can use these tools to just, partially transfer. So let's say I want to bring across some wall types. Well, if I did a transfer project standards, it's going to bring them all across. I don't want to do that. So maybe I just want to bring across the cladding. I can see I've just managed to bring across a selective portion of elements. And behind the scenes of all these tools is generally a fair amount of work. These ones are a little bit harder to understand because I use libraries. And I'll show you libraries very quickly. So you can use Alt-click to go to the source of a tool. So I'm showing you the inner workings of this here. Now this looks very simple, right? Looks like a very small tool. But what it's actually doing is importing libraries. So I'm importing a copy utility library here. And this is giving me a function called copy by class. I'm passing to it wall types and then a couple of messages for the UIs. But if I go to the library folder in pyRevit, well, you'll start to see something a little bit more complicated. If I go to copy utilities, well, here we go. This is actually what is being run. So in this case, I think I was using the copy by class. And you can see in this case, okay, now we have a real function doing some things, but this means I can refer to this function across multiple scripts together and not have to write this out multiple times. So I use libraries quite a lot to reduce the amount of work that I need in order to connect all my tools to similar functions. It's a little bit like building custom nodes with a little bit more planning behind it. There are other tools, for example, bulk exporting and printing. The one that we use is quite proprietary, so I probably won't show it. We have bulk importing of sheets, various view tools, some interesting ones with funny names sometimes. Not all of these are going to work in this model just because it's very particular. Some are just very interesting, like for example, maybe I want to see the last set of views that were created in the model. Well, I can ask the model what the last 20 views were based on the quantity of their ID. I can say the last view that was made is a render board, and I can sort of go backwards through them, which is really convenient when you're working in a model and you need to see the last couple of views you created. There's a lot of other stuff in there. There's a few jokes, such as AI for Revit, which is a autoplay rickroll. Obviously not real AI, but we have a lot of fun with pyRevit. guRoo is a smaller set of tools, some commonality, not all commonality, of course. such as a home button, because I think that's a really good tool just to have regardless of which toolbar you're using. Various links and folders. For example, maybe I want to open up the Aussie BIM Guru GitHub, or there we go. To do that sort of stuff, I'm just using a web browser library. So if I open up this tool and I look at the code, very simple. I'm using a web browser library, which comes with pyRevit, and I'm opening a URL. That's all it takes. I've got pre-selection tools in here. Some are provisioning tools, some commonality. I've got the ability to create work sets from a predefined list, which is stored inside pyRevit, and I might show you how I've done that because that's pretty cool. So I'm making this project workshed. And after this, I'll initiate the creation of some work sets. So I go work sets, create using BIM Guru system. It's going to ask me to rename shared levels and grids to my standard, but then we can pick from a list of work sets to apply. And I can create 10 new work sets, and there they are to a particular standard. We have a very similar script at Architectus because work set creation is typically a fairly standardized process. But if I do want to draw upon resources, one really great method I can use is get the path of the script and split up the string at the point where I know I can get to the bin of the package. And the bin is usually where we just store lots of little resources that can be used. So if I go back to the extension, into the bin, I can see I've got some standards such as BIM Guru worksets. And I can just ask pyRevit to display everything in this list in a list of sheets. And from this, I have a list of potential workset names. So there's some really fun little tools you can build like that. As well as this, you can do things like take advantage of the bulk export PDF tool. So in this case, I can say sheets to PDF. I can pick a bunch of sheets and off it goes. Now I think in this case, there's going to be a missing function. I probably need to fix that. I'm still developing that tool. But we have various other things too, such as creating sheets from an Excel file. Lots of little examples that show how you can really bring together a toolbar in pyRevit. Obviously nowhere near to the point of what I do for a real company for money. Obviously that's why I can't show you everything. For example, our bulk export tool is very different. It has a lot more features built into it. But ultimately it's enabled me to create some really smart and accessible tools for the company, and also enabled me to create some personal tools that really just help me when I'm working, and also let me share a little bit of the good stuff of what I like doing with the industry still. So there's just some examples. So I guess the point is that this is all really great, but it is free. The person that runs it obviously is only making so much money. At the moment, they make about $750 Australian per month, which might seem like a lot, but in a Western economy, it's not really for the amount of work that goes into it. I donate $50 a month personally, just because I use pyRevit enough that it makes my life more fun. So if you are interested in becoming another patron, maybe number 40, I'm not sure how many are there now, but I think I was 39, definitely consider joining the Patreon to support Asan directly. I hope it's been an interesting presentation, and feel free to ask me any questions through the comments. Thanks again to Sofia User Group for hosting me for this presentation specifically. Of course, if the question is, can you give me your toolbar from your company? The answer is no, but the guRoo toolbar is available on my GitHub. I might very quickly just show where that's located. So if I go to the Aussie BIM Guru GitHub, you'll find a repo or repository on there called guRoo. And that will just contain the folder structure of guRoo to establish, as well as just a very quick guide on how you can install guRoo and get going with it. I will fix that bug that I found by the time you watch this presentation, but I hope that you found it a useful reference, especially if you're learning pyRevit. Otherwise, if you're not already following and subscribing the channel, feel free to do so. I make videos once a week and will aim to do so as long as I can. And I look forward to seeing you in future similar video topics. Thanks. Take care. Bye.